Exercise number 1.1, question number 1. In that question number 1, we are doing this fifth bit from Relations and Functions chapter, class 12th mathematics. In this fifth bit, again another 5 bits are there. In this class, we are going to learn all these 5 bits. If you observe the question, what they given, R is a relation on set A. And what is set A? Set A is human beings in a town at a particular time. And relations are there, 5 relations are there. We need to check these relations are reflexive, are symmetric, are transitive. Those things we need to check. If you observe last 4 bits in first question, we mainly written 3 points. First one is relation is on which set. Here set is set of humans in a town. First I'll write that. What is A? Given set A is set of humans in a town at a particular time. Second one is relation is on which set. You see here R is a relation in the set A. They given that R is a relation on A. R is a relation on A means R is a relation from A to A. And finally, given relation. In A bit, the relation is given like this. Order pair x comma y such that x and y work at same place. Here, R is a relation on A. So, x is there in set A. That means x is a human in a town. What about y? Y is also human in a town. Which order pair belongs to this relation? That is important. Which order pair belongs to this relation? First point, x, y must be humans in a town at a particular time. They must be humans and x and y work at a same place. For example, I take in that x, y work at a different place. Suppose x and y work at different companies. In that case, this order pair x comma y does not belong to this relation. You need to understand which order pairs are there in this relation. To be a part of order pair in this relation, only when they work at same place and those two are from set A. Now we will check a reflexive condition. What is reflexive definition? For every x in set A implies order pair x comma x is in the relation, then we say that that relation is reflexive relation. For every x in set A, I'll take one human being from this set. Let's see what happens. I take in for any x in set A, that means x is a human being. You observe this, x and x works at same place. X and x. These two x are different. No, actually, x is a person in a town, same person. Can I say that x and x works at same place? Yes, we can say that x and x obviously will be at the same place where x is working. X works there only. A simple thing, nothing is there. Actually, it's funny to think about it. X and x works at same place is true. For any x belongs to A, x and x work at same place. From this, we can write that the order pair x comma x belongs to the relation. So we came to know that for any x belongs to A, order pair x comma x belongs to this relation. So I can say that this relation is reflexive. Therefore, the relation R is a reflexive relation. Now I'll check this relation is symmetric or not. How to check symmetric condition? For every order pair x comma y in the relation, the order pair y comma x is also in the relation. Then we say that that relation is symmetric relation. First, we'll take one order pair from this relation. You take one order pair x comma y in the relation. If order pair x comma y is in this relation, it indicates that x and y work at same place. As order pair x comma y belongs to this relation, that indicates that x and y work at same place. As we take an x comma y in the relation R, you need to check that y comma x is there in the relation or not. When y comma x belongs to this relation, if y and x works at same place. If x and y works at same place, from that can I say that y and x also works at same place? See, it's a simple thing, no need to think much about these things. X and Y work at same place. Obviously, Y and X also works at same place. Suppose two persons are there, A and B works at same place. Can I say that B and A also works at same place? Yes. If Y and X works at same place, then what I can write? I can write that the order pair Y comma X belongs to the relation. So what I got here, for every x comma y in the relation, y comma x also belongs to this relation. So I can write that this relation is symmetric. Therefore, the relation R is symmetric. Now we'll check a transitive condition. What is transitive condition? For every pair of order pair x comma y belongs to R and y comma z belongs to R. If such pair exists, then we'll look that x comma z is there in the relation or not. For such pair, if x comma z is there in the relation, then we say that that relation is transitive. First, you take x comma y belongs to R and y comma z belongs to R. You take such order pair in the relation. X comma y belongs to R, it indicates that x and y work at same place. As we written x comma y belongs to R, it indicates that x and y work at same place. As we taken y comma z belongs to R, it indicates that y and z works at same place. X and y works at same place. Y and z also works at same place. You please observe. It indicates that suppose X and Y work at company A, works at same place, works at company A. Y and Z works at same place. As Y is working at A, Y and Z also works at A. This indicates that X and Z works at same place. This is very simple thing. How to explain this? It is easy. With common sense we can understand. If x and y work at same place, y and z also working at same place, that means here y is common in both. That means all these three are working at the same place. So I can say that x and z works at a same place. As x and z works at same place, from this I can write that the order pair x comma z belongs to the relation. So what happened here? For every x comma y comma z belongs to R, x comma z also belongs to R. Therefore, the relation R is transitive. So, if you observe this relation, x and y works at same place, this relation is reflexive, this relation is symmetric, this relation is transitive. What I'll do, this reflexive I'll take it as 1, this symmetric I'll take it as 2, this transitive I'll take it as 3. From 1 to 3, we can say that the given relation R is an equivalence relation. What is equivalence relation? If a relation is reflexive, symmetric, transitive, then we say that that relation is equivalence relation. I hope you understand the solution of this A bit. If you observe the B bit, actually A bit, B bit almost same. You observe A bit, they are saying that X and Y works at same place. And in this they are saying that X and Y live in the same locality. So this relation is also equivalence relation. Both are similar. Let's see the solution of this quickly. I'll quickly explain this B bit. As usual, total 3 points will be there in this type of problems. First one is set A. What is set A? Set of humans in a town at a particular time. R is a what? R is a relation on A. These things given in the question. And the relation is defined like this. R is a relation set of order pairs x comma y such that x and y live in the same locality. Last problem is x and y work at same place. Here x and y live in the same locality. Now reflexive relation. Let's see how to write the answer for this. You know what is reflexive definition? For any x belongs to A, order pair x comma x belongs to the relation, then we say that relation is reflexive. Here I taken one X in set A. That means X is a human in a town. Now, if I say like this, X and X lives in the same locality. Suppose X is the same person. Where X is there, X will be there only. It's a simple common sense thing. X and X lives in the same locality. If I say like this, anything wrong in this statement? Where X is living there only. Yes, X and X live in same locality. We can say like that. So whatever I written here, that statement is true, right? So from this, if X and X live in the same locality, then the order pair X comma X belongs to the relation. So I written here order pair X belongs to this relation. Therefore, the relation is R is reflexive. I taken it as 1. Now I'll check this relation is symmetric or not. Symmetric. What is symmetric condition? If you take an order pair x comma y in the relation, y comma x also belongs to the relation, then we say that that relation is symmetric. Suppose I taken any for some order pair x comma y in the relation. When the order pair x comma y belongs to the relation, if x and y live in the same locality, right? Use your common sense. You know this point, x and y live in the same locality. If x and y live in the same locality, we can easily say that y and x also lives in the same locality. It's a common sense related thing. You can understand this easily. If x and y lives in same place, y and x also live in the same locality, right? So I can say that this statement is also true. As y and x lives in the same locality, from that I can write that the order pair y comma x belongs to the relation. So for every order pair x comma y belongs to R, y comma x also belongs to R. Therefore, we say that this relation is symmetric. Now I'll check transitive. For transitivity, we will take a pair of order pairs like this. X comma y belongs to R and y comma z belongs to R. If x comma y is there in the relation, that itself indicates x and y live in the same locality. Y comma z belongs to R. This indicates that y and z lives in the same locality. You observe in these two statements y is common, right? That means suppose y is in a some location of a, right? Here y is some location of a. So x and y in location a, y and z also in location a. From this we can say that x and z are in the same location, right? From this we can say that x and z live in the same locality. This is common sense related. You can understand this easily. So as x and z lives in the same locality, I can say that the order pair x comma z belongs to the relation. So for every pair of such order pair x comma y comma z, x comma z also belongs to this relation. I'll say that this relation is transitive. So if you observe this relation is reflexive, this relation is symmetric, this relation is transitive. From 1 to 3, we can say that this relation is equivalence relation. I hope you understand the solution of this second bit. You observe this C bit. A is a set of humans in a town. R is a relation on A, and the relation is like this. Order pair x comma y such that x is exactly 7 centimeters taller than y. Now you need to check this relation is reflexive or symmetric or transitive. First we'll check reflexive condition. What is the definition of reflexive? For every x in set A implies order pair x comma x belongs to the relation, then we say that that relation is reflexive. Here I'll take one x from set A. For any x in set A, I taken one x from this set A. A contains all human beings. You observe this what I written here. X is exactly 7 centimeters taller than x. X is one person. Here x is also same person. Is it possible that one person is exactly 7 centimeters taller than same person? Suppose you are a height of 5 feet. Can I say that you are exactly 7 centimeters taller than your height? Can I say like that? No, this is false. So x cannot be exactly 7 centimeters taller than x. When the order pair x comma x belongs to the relation, if x is exactly 7 centimeters taller than x, then only this order pair belongs to this relation. Here x cannot be exactly 7 centimeters taller than x. Na? This indicates that the order pair x comma x does not belong to this relation. Therefore, the relation R is not reflexive. This relation R is not reflexive. Now I'll check symmetric condition. What is the definition of symmetric? For any order pair x comma y, if we take in the relation, order pair y comma x also present in the relation, then we say that relation is symmetric. I taken one order pair x comma y in the relation. If x comma y belongs to R, what it mean? If x comma y belongs to R, it indicates that x is exactly 7 centimeters taller than y. Suppose you observe here, this is x, this is y. Okay, you suppose that x is exactly 7 centimeters, x is exactly 7 centimeters taller than y. Is y is also exactly 7 centimeters taller than x? No, actually y is exactly 7 centimeters shorter than x. Okay, when we say y comma x belongs to the relation, when we say y comma x belongs to the relation, if y is exactly 7 centimeters taller than x, then only we say that y comma x belongs to R. As we came to know that x is exactly 7 centimeters taller than y cannot be exactly 7 centimeters taller than x. Moreover, if we speak correctly, y is exactly 7 centimeters taller than 7 centimeters shorter than x. Y cannot be exactly 7 centimeters taller than x. It is not possible. This is not possible. Y is exactly 7 centimeters tall, shorter than x. Okay. From this, I can write that the order pair y comma x does not belong to the relation. So, as per the definition, for every x comma y belongs to R, y comma x also belongs to R. Here, y comma x does not belongs to R. So, I can write that the relation R is not symmetric. So, this relation is not symmetric. Now, we'll check transitive condition. What is transitive condition? For any pair of order pair x comma y belongs to R and y comma z belongs to R, then we look that the order pair x comma z is there in the relation or not. If such order pair x comma y comma z exists and x comma z also belongs to R, then we say the relation is transitive. I'll take an order pair x comma y belongs to R and y comma z belongs to the relation. X comma y belongs to R. What it represents? X comma y belongs to R represents that x is exactly 7 centimeters taller than y. Y comma z belongs to R. What it represents? Y comma z belongs to R represents that y is exactly 7 centimeters taller than z. Here you need to observe few things. First you see x is exactly 7 centimeters taller than y. Suppose this is x. X is exactly 7 centimeters taller than y. Okay. And y is exactly 7 centimeters taller than z. What is the relation you will say about x and z? X is exactly 14 centimeters taller than z. You please try to understand. X is exactly, see this difference is there, na? This is 7. This difference is there, na? This is 7. 7 plus 7, 14. X is exactly 14 centimeters taller than z. That means x comma z belongs to the relation. When x comma z belongs to the relation, if x is exactly 7 centimeters, exactly, try to understand, they are saying x is exactly 7 centimeters taller than z, then only that order pair belongs to the relation. Here they are saying that x is exactly 14 centimeters taller than z. That means the order pair x comma z does not belong to the relation. The order pair x comma z does not belongs to the relation. So for this order pair x comma y belongs to R, y comma z belongs to R, we came to know that the order pair x comma z does not belongs to the relation. From this we can say that the relation R is not transitive. Therefore given relation is not reflexive. it is not symmetric, it is not transitive. I hope you understand solution of this bit. These are bit easy only. With a little bit of common sense, you can understand this solution very easily. You observe next bit in this question. They are saying set A is set of all humans in a town, and they are saying R is relation on set A, and order pair x comma y says that x is wife of y. Actually, it is funny question. See, which order pair belongs this relation? If x is wife of y, then only that order pair belongs to this relation. Suppose x is brother of y. You suppose x is brother of y. As that order pair x comma y belongs to this relation? No. This relation contains order pairs in which x must be wife of y. Right? Suppose y is wife of z. Then the order pair y comma z belongs to this relation? Yes, the order pair y comma z belongs to the relation. You need to understand what type of order pairs are there in this relation. Okay. Now we need to check is this relation is reflexive or not. What is reflexive definition? For every x in set A implies the order pair x comma x is there in the relation. Then we say that relation is reflexive. Okay. For any x in A, I take an x in set A. That means x is a human. Okay. When what to check? We need to check order pair x comma x belongs to the relation or not. When x comma x belongs to R, if I say x is wife of x, if x is wife of x, then the order pair x comma x belongs to the relation. Okay. You observe x is wife of x. How funny it is. X is wife of x. Is it possible? Is it possible that x is a wife of x? Any person is there? Is it possible that the person is wife of oneself? No, it's not possible. X cannot be a wife of x. This is not possible, right? So the order pair x comma x belongs to relation or does not belong to relation. If x is a wife of x, then only order pair x comma x belongs to relation. Here x cannot be wife of x. It is not possible. So we will write that the order pair x comma x does not belongs to the relation. Therefore, the relation R is not reflexive. This relation is not reflexive. Now we'll check symmetric condition. What is symmetric? For every order pair x comma y in the relation, if y comma x also belongs to the relation, then we say that that relation is symmetric. First, I'll take one order pair in the relation. I taken one order pair in the relation. When the order pair x comma y belongs to R, what it indicates? It indicates that x is a wife of y. If x is a wife of y, then only the order pair x comma y belongs to R. As I taken one order pair in the relation, this indicates that x is wife of y. If you observe the funny part here, x is wife of y means x is female in general, correct? X is wife of y means x is female, y is male. Okay. Now what you need to look? You need to look that y comma x belongs to R or not. When y comma x belongs to R, y is wife of x. If y is wife of x, then y comma x belongs to R. One person can be a wife of some person means y must be female, right? As here x is wife of y, we already know that x is wife of y. That means y is a male. Male person cannot be wife of some person. Male person can be husband. I hope you are understanding. I need to look for y comma x belongs to the relation or not. But y comma x cannot belong to this relation because as y is a male, y cannot be a wife of some person. So y is a y cannot be a wife of x. From this what I can say? I can say that the order pair y comma x does not belong to the relation. Therefore, for an order pair x comma y in the relation, y comma x does not belong to the relation. Therefore, I can write that the relation R is not symmetric. This relation is not reflexive. This relation is not symmetric also. Now we'll check transitive condition. What is transitive condition? For any x comma y belongs to R, and if y comma z belongs to R also exists, then for this pair of order pairs, we look that x comma z exists in the relation or not. Here important thing is, if x comma y, y comma z doesn't exist in the relation, in that case no need to look for x comma z. We directly say that that relation is transitive, that we already discussed in earlier problems. In the theory part also we discussed. If x comma y, y comma z exists, then we look for x comma z. If x comma y, y comma z doesn't exist, then we don't look for x comma z. We directly say the relation is transitive. Okay. First thing, I'll check that x comma y, y comma such type of things exist in the relation or not. We'll check. Here, the order pair x comma y belongs to R itself indicates that x is a wife of y. The order pair y comma z belongs to R, it indicates that y is wife of z. Now it is important to check that this type of things will exist or not. Suppose x is wife of y. X is wife of y means x is female, y is male. Please observe this carefully. As y is male, is it possible that a male person is a wife of some person? This person may be anything. Here the question is, as y is male, is it possible that y is wife of? Y can be husband because y is a male person here. So what happened? For order pair x comma y, y comma z doesn't exist in the relation. You try to understand. If x comma y, y comma z exists, then only we look for x comma z. If x comma y, y comma z, such pair of order pair doesn't exist, in that case we say that that relation is transitive. So what is the conclusion we'll write? For the order pair x comma y in the relation R, there doesn't exist y comma z in the relation. If x comma y, y comma z exists, then only we look for x comma z. As for x comma y, y comma z, that type of things doesn't exist. In that case, we say that the relation is transitive. I hope you understand. See, these things we discussed in the theory part while discussing definition of transitive relation with the help of examples. At that time, I explained this more clearly. So, this relation is not reflexive, not symmetric, but this relation is transitive. I hope you understand solution of this problem. Actually, it's really easy. You may confuse in this, nothing to confuse, especially in transitive part. We discussed it more clearly about this. If x comma y, y comma z exists in the relation, then only we look for x comma z. Otherwise, we say that that relation is transitive. I hope you understand this. You observe this A bit, it is similar to D bit. In this, 3 points you need to observe. Given set is set of humans in a town. They are saying that R is a relation on set A. And the relation is like this, which contains order pair x comma y. And when we say order pair x comma y belongs to R, if x is father of y, then only order pair x comma y belongs to R. Suppose x is wife of y. Suppose x is wife of y. In that case, can we say order pair belongs to this relation? No. If x is a father of y, then only x comma y belongs to the relation. Okay. Now I need to check this relation is reflexive or not. What is reflexive condition? For every x in set A, order pair x comma x is there in the relation or not. This we need to check. Okay, I taken one x in A. A contains all human beings. Here x is a human being. Is it when we say x comma x belongs to R, if x is a father of x is a father of x, then we say order pair x comma x belongs to this relation. Is it possible? How funny it is. One person can be father of himself. No, it's not possible. It is a common sense thing. You can easily understand that x cannot be father of x. If x is the father of x, then only the order pair x comma x belongs to this relation. As x is not a father of x, the order pair x comma x does not belong to the relation. as order pair x comma x does not belongs to relation, we can say that this relation is not reflexive. I hope you understand this. Now we'll check symmetric condition. What is symmetric condition? For any order pair x comma y belongs to R, y comma x also belongs to relation, then we say it is symmetric, right? Now I taken one order pair x comma y in the relation. What it mean? It means that x is a father of y. When I can say y comma x belongs to the relation, if y is father of x, if y is father of x, then I can say the order pair y comma x belongs to this relation. Okay. If x is a father of y, here what you need to observe, if x is a father of y, it means that x is a male, y can be male or female, then y is son of x or y is daughter of x. You try to understand. Y cannot be father of x. It is impossible. Y cannot be father of x. If y is father of x, then only y comma x belongs to R. As y cannot be father of x, we can say that the order pair y comma x does not belong to this relation. Therefore, this relation is not symmetric. Now, we'll check transitive condition. What is transitive condition? For every such pair x comma y comma z exist in the relation, then we look that x comma z is there in the relation or not. Okay, first I taken x comma y comma z in the relation. X comma y belongs to R means x is a father of y. X is a father of y and y is a father of z. First we'll check that x comma y comma z such pair exist or not. You suppose x is a male, y is also male. Just suppose such pair exists or doesn't exist. If x is male, y is male, x is a father of y. Yes, it is possible. As y is male, y can be father of some z. What I am trying to say, in this relation, there exists a pair of order pairs x comma y comma z. X comma y comma z, such type of pair will exist in the relation. That's what I am trying to say. If x is male, y is female, in that case, female cannot be father of z. You try to understand, right? But the point is, such pair exist in the relation or not? Yes, such pair exists. When x is male, y is male, then y can be father of z. If x is father of y is father of z, then what is the relation between x and z? X and Z relation is X is a grandfather of Z. You can easily understand these things, man. No need of any example for this. You can understand it easily. X is a grandfather of Z. When X comma Z in the relation, if X is a father of Z, there is so much difference between grandfather and father, right? If X is a father of Z, then only X comma Z belongs to R. Here X is not a father of Z. X is a grandfather of Z. That means the order pair x comma z doesn't belong to relation. Therefore, this relation is not transitive. This relation is not reflexive. This relation is not symmetric. This relation is not transitive. I hope you understand the solution of this E bit. So we done total 5 bits in first question, 5th bit. I hope you understand all these solutions. See, creating videos takes so much of time. If you drop a like for this video, it gives me more energy to do many videos like this. If you like this video, please drop a like and share this video with your friends. In case if you are not yet subscribed to my channel, subscribe now. Thanks for watching. Take care. Bye bye.